Differentiation can be used to help us find the equation of a tangent or the equation of a normal to some given curve. So if we just have a quick look at the diagram, a tangent to a curve, so remember from GCSE, a tangent touches a curve at one point. So the gradient of the tangent is exactly the same as the gradient of a curve at that specific point where they meet. Now a normal to a curve meets it at right angles, so its gradient is the negative reciprocal to the gradient of the curve, so they're perpendicular to each other. So if we can find the gradient of a curve, we can use that information to determine the gradient of a tangent and the gradient of a normal. And remember, tangents and normals are just straight lines, so to find the equation of a straight line, we're back to our key stage 3 maths, or y equals mx plus c. If we have a look at the example then, and we'll go through how we put this into practice. So the example we've been given wants us to find the equation of the tangent and the normal to the curve y equals x squared minus 2x at a certain point, which is 3, 3. So what we need to do first is start by differentiating, get the gradient of the curve at that specific point 3, 3. So the differential dy by dx is 2x minus 2. Now let's find the gradient of the curve at the point we've been given. So when x equals 3. So if we fill in 3 to our dy by dx, we get the gradient of the curve to be a 4. Now we know the gradient of the curve, let's take it step by step. Let's work with the tangent first. So remember, the gradient of the curve and the gradient of the tangent are the same. So the gradient of the tangent is therefore 4. Now a tangent is a straight line, so it has a general equation y equals mx plus c. So we know that m is the gradient and it's 3, so let's fill it in. So we start off with the equation y equals 3x plus c. Okay, to find c then, the y-intercept, all we're going to use is the coordinate we've been given. So we want the equation of the tangent at the point 3, 3. So x equals 3 and y equals 3. Let's substitute that into our equation for a straight line. And we end up getting c to be minus 6. So filling that into the general format, we get our equation of the tangent to be y equals 3x minus 6. Now on to finding the equation of the normal. So the gradient of the normal is going to be minus 1/3 as it's perpendicular to our curve. Again, the normal is a straight line, so we're using our y equals mx plus c. Filling in our gradient, we have y equals minus 1/3 x plus c. Again, we want the equation of the normal, and we know it's at the point 3, 3, so if we substitute in x to be 3 and y to be 3, it will allow us to determine a value for c, the y-intercept. So in this case, c is working out to be 4. And finally, once we've got c, then we can fill it into our equation for y equals mx plus c, leaving the equation in terms of x and y. And we get y equals minus 1/3 x plus 4. Now, sometimes in the exam, quite frequently in C1, they ask you to write it in the form of ax plus by plus c equals 0. So basically, you've got to multiply through by the denominators of any fraction and bring everything to one side. So if it states in an exam question that you must leave it in that format, ax plus by plus c equals 0, make sure you do or you will lose a few marks. So first thing, if we times through by the 3, we get 3y equals minus x plus 12. Make sure everything is multiplied through by the 3. And now bringing all the terms to one side, you get 3y plus x minus 12 equals 0. And just rearranging that, x plus 3y minus 12 equals 0. So just watch out for the wording of the question.